So, good morning, dear students. So, today we will be discussing network topology. So, last class I've told about network topology. It is about the appearance, how you are going to form a network. That is the actual appearance or layout of the network is called topology. There are different types of topology like bus topology where we use a common wire and all our workstations node are connected. All individual computers are connected to common cable. So this is a bus topology, and also we have a ring topology. In ring topology, all computers, that is individual computers or networks, are connected in one after the other in the form of ring. And this is star topology. There will be a central hub where all the computers of the networks are connected to the central computer. And then we have a extended star topology, that's a hybrid. So a hybrid topology, and also we have a mesh topology. So we'll discuss all one by one, and also it's very interesting. So it's something about the actual structure. So when you want to connect computers, like many computers together, so what are the methods? How do you connect? So you can form any method. So there's like you can use in the form of bus topology, like common cable, or either the side of the cable we can connect computers, or in a single cable. So one after the other. Also you can connect in the form of ring, and also connect in the form of star like this, and also use combination star and bus topology. So tree topology we call hierarchical topology or something like that, and also mesh topology, that is less commonly used. So now let us learn one by one. The first one, let us learn something about the star topology. So in star topology, so all the computers, you can see here, or many computers are connected to each other to the common computer. This is we call as a hub. So where all computer has to communicate through this hub, and this is how it will be able to share the resource among the computers. So there will be a central computer that is called as a uh, main server. So through this server, all the computers are able to communicate. So let us learn something about this. This topology consisting of central node, that's a central computer to which all other nodes are. These are the individual computers. Node means workstation. All other nodes are connected by a single path. You can see here, from this we have a single path, from this also we have a single path, from this also we have a single path. So only one like connection. And it is the topology most existing information network involving data processing or voice communication. This is the most of the common. So whereas data processing is required and also voice communication. So in those places we use this type of network. There are some advantages and disadvantages of star topology. So advantages is, so ease of service. The star topology has a number of concentration points where connections are joined. So these provide easy access for services or reconfiguration of the network. So in star topology, number of concentration points where connections are joined. So these provides easy access for services or reconfiguration of the computer. You can see here we have, these are the points. So here you can have a number of points. So where you can easily modify or reconfigure or connect other computers easily, like this you can form one more. So this becomes easier. So easy of service. Maintenance of computers, such computer networks is easier. So another is one device per connection. So connection point in any networks are inherently prone to failure. So normally whenever we have many computers are connected, the connection may fail. In star topology, failure of a single connection typically involves disconnecting the one node from an otherwise fully functional network. Could have done in simple words. I do not know why they made like this. So in this case, what happens means, so if this computer is not working means, so this connection can be broken. So this broken connection has no effect on other computers which are the network, like that's one computer for connection. So now because this computer is actually we have a computer. So through this also connected to computer. If any one of the computer is not functioning, it does not affect the entire network. So if it is not working means, so that computer can be disconnected. So nothing will happen to network. Still the network functions well. That is what the advantage is. One device per connection. Connection points in any networks are inherently prone to failure. Other type of networks in the start of in this topology, failure of a single connection. So failure of this computer typically involves disconnecting that node. So we are disconnecting this node from the network, otherwise fully functional network. So otherwise it works as usual, there is no problem. So just you disconnect whichever is not functioning. That's advantage. One is easy of service, another is the one device for connection. So that is the advantages of star topology. So now let us learn something about the bus or linear topology. So this is one of the popular. So another popular topology for data network is a linear. So linear means where one after the other. So this consists of single length, already I have told. So we have single length of transmission medium, normally coaxial cable. We have a common cable onto which the various nodes are attached. So all the computers are attached either side. So we have a common cable like this, and then you can connect many computers in either side of the computers. The topology is used traditional data communication network, so normal traditional data communication. So where the host at one end of the bus communicates with the several terminals attached along with its length. So we have a common cable like this, and all the computers will able to communicate with each other. So one end we have a computers, and all other computers are able to communicate. So normally we have data communication and where the host, this is actually main computer, one end of the bus communicates with several terminals attached along with its length. So we have a common cable, it runs, and then we have one end, we have host computers. So from this, data has to be transmitted to all other computers. So through this cable, all computers are able to receive and communicate. So that is something about the linear bus topology. The transmission from any station travels the length of the bus in both directions, so and can receive by all other stations. The bus terminators at either ends which absorbs the signal, removing it from the bus. So data transmitted in a small blocks known as the packets. Each packet has some data bits plus header containing its destination address. A station wanting to transmit some data sends it in packet along with the bus. The destination device, on identifying the address on the packets, copies the data onto its disk. So normally what happens in bus topology or linear bus topology means the transmission of any station from any computers travels the length of the bus till from beginning to the end of the bus in both directions. You can go in any directions and can be received by all other stations. So each machines will receive and then transmit. The bus has a terminators at either end. So where the common cable after the reaching the dead end, so there is a terminators. So that helps to identify the electrical signals. We have reached the dead end. So which absorbs the signals removing from the bus. If you reach the dead end, so automatically it absorbs and removes from the bus. So that signal will be lost. So that is how it will be terminated. That's how it terminates. So how it works means then, so data is transmitted in a small blocks. So that is we already known about packets. So each packet has some data bits, normal actual data, plus also header that is containing the destination address where it has to be transmitted. A station wanting to transmit some data sends its packet along the bus. So then what happens is the data which has to be sent from the source to destination means, so it just relay on the cable, that's a bus, along the bus, so it sends. So then the destination device, on identifying the address, it copies to its disk. For example, so this is a terminator, so where this is, so both, so along with this data will transmit like this, it goes like this. And if it reaches dead end, so the signals will be, that is what we call, it is absorbed, so there is no data. Now normally this want to send to this computer, imagine I want to send from this computer. So how data will be sent means, so along with data to be sent and also attach the address of this node on the network. And then whenever data is transmitted, so it comes and leaves to the bus. And what it does means it goes to this bus first. On this bus first it decides whether it is addresses this one or not. No means again it is retransmitted. So it goes here. All the networks receives. No means comes back. Again it goes. No means again it comes back. No means it comes back. And finally it reaches and it copies the data. So that's how data transmission takes place in linear bus topology. There are some advantages and also we have a disadvantages. One is the short cable length and simple wiring layout. So you can see very simple. So because there is a single common data path connecting all nodes, the linear topology allows a very short cable length to be used. So this decreases the installation. This is very important. Installation cost and also leads to a simple, easy to maintain wiring layout. Because common cable is involved, only one cable is involved with all the computers over the network. So one, of course, the installation cost is less. It takes less amount of money. And also it's a simple and easy to maintain wiring layout because there is only one cable. If anything happens, you just replace the cable or any modification can be done easily. And also it's a very simple network. So a short cable length. So normally we do not take kilometers together. So it's a short length. So therefore short cable length and simple wire. It's not any logic. So we have to make this or that way some designs. No, simple cable. Because there is a single common data path connecting all the nodes, the linear topology allows very short cable length to be used. So this decrease this is what advantages. The installation cost and also leads to a simple network and easy to maintain the wiring layout. So next we have one more advantage is a resilient architecture. The linear architecture has an inherently simplicity that makes it very reliable from hardware point of view. There is a single cable through which all data propagates and to which all nodes are connected. So you can dependent on this. It's a very reliable architecture. What happens? It's a very simple already we know. So from the hardware point of view, there is nothing will happen because only one cable is there. All data propagates with all the nodes which are connected to the network. So there is no difficulty at all. So if anything data is collapsed, if it's because electronic device there is a possibility of electronic components may not work sometimes because of it's a complex if there's because it involves only a single cable, so you can reliable. That's one more advantages of this bus topology. And one more is a very simple, so extending the network, so easy to extend. Additional nodes can be connected to existing bus network at any point along its length. So more extensive additions can be achieved by adding extra segments connected by a type of a signal amplifier known as a repeater. So it's also very easy to extend. So if there is a space, sufficient space, so to the same common cable, you can connect one or more nodes. Otherwise, you can extend by using the repeaters like amplifiers. So you can connect one more linear bus topology, another 4 computers, then you connect them, these two together, because signal has to travel from source to destination for a longer distance. So the strength of the signal becomes weak to amplify. So we use amplifier repeaters. They take this electrical signals and amplify them and rebroadcasting like amplifier only. So that is we call them as repeaters. I think physics you might have studied about amplifiers. Exactly the same amplifier is used here. So it rebroadcasts for a longer length because we are connecting other network to this network to extend. That's also easy. By using amplifier, you can easily modify or easily extend the computer network when you have a linear bus topology. So disadvantages. So there are disadvantages means fault diagnosis is difficult. Although simplicity of the bus topology means that there is a very little to go wrong. Normally the error may not occur, but there is a possibility of error. Fault detection is not simple matter. Control of the network is not centralized in any particular node. So this means that detection of fault may have to be performed from many points in the network. So fault diagnosis means normally we have only one cable, so all computers are connected. We may not be knowing which computer is not functioning, detecting where the actual error is occurred. So to do this, we have to visit all the nodes, we have to check all the computers, and then we have to identify the exact computer which is not functioning. So that's the most difficult. Suppose you are sending some destination machine and that may not be performing. That's maybe gone down in the network. So we cannot know easily because there's a cable that's attached. So we do not have other media. So only option is if such error occurs means identifying whether it is reached or not means we have to go with each computers and then check whether all computers are functioning properly. That's what the fault diagnosis, whether particular system, because if it is connected to one of the central computers, centralized, then what happens means that centralized computers as a signal that particular computer is not functioning. So this is not so in this type of computer network. So that is the disadvantages of linear topology. The second, fault isolation is difficult. So identifying and keeping that computers away from this network is also difficult. So in the star topology, a defective node can easily be isolated from the network by removing its connection at the center. If node is faulty on the bus, it must be rectified at the point where the node is connected to the network. So in this case, we cannot remove. So if it is a fault means, then it has to be rectified at the point where the node has been connected to the network. So there only we have to repeat. We cannot isolate. We cannot remove from the network. So we have to rectify that problem. So that's difficult again. Fault identifying, fault isolation is also difficult. Repeater configuration. So already I told whenever you extend the network, then the repeaters is required and additional hardware is required and configuration is also required to connect these networks. So this is extended network. That's why it is difficult. It's not like just connect one more cable and add this. It's not like that. So it has to be configured. So that is quite difficult for common, whenever normally we use just computer network. So repeater configuration. So when a bus type of network as its backbone, so normally bus, the common cable is the backbone of the network. So extended using repeaters. Whenever we extended using repeaters, so configuration may be necessary. We have to configure this. That is one, and also additional cost for repeaters may be used. So this is maybe not much expensive, but still it's additional cost used. So repeater configuration is required. That's a drawback. And one more drawback is nodes must be intelligent. Because why nodes must be intelligent means each node on the network is directly connected to the central bus, common bus. This means that some way of deciding who can use the network at any given point of time and must be performed in each node. So now because all common cable is there and all computers are connected. So whenever data is being sent, so should I send now? So somebody is sending. So it must be some side, sort of intelligent who should use the central bus, and also they must use each like store and forward. So you send some computers, even if not my destination machine means I have to check and then I have to forward. So that's why it also becomes slow sometimes. So that's something about the disadvantages of bus topology. So nodes must be intelligent. I think you have understood. And also repeater configuration is required. Fault isolation, fault identifying the fault is difficult. So these are the disadvantages of what we call linear topology or bus topology. So next one is the ring or circular topology. This is one of the another topology that we will consider is the ring or circular. In this case, each node is connected to only two neighboring nodes and is transmitted onwards to another. Thus, data travels in one direction only from node to node around the ring. So after passing through each node, it returns to the sending node, which removes it. So it is very simple. So this is network means we have server. It starts from like it's a unidirection. Go to from one computer to other computers, other computer, other computer. No means it removes like this. So this is simple. This is a unidirection. We have to like client server. All the computers are connected to this in a unidirection. So it's like one direction. I cannot send like this. From this computer, it has to go to this. From this computer to go. If you want to send from this computer to this computer, is not possible. So from this computer, you want to send this means it has to go like this. From this computer, we have to reach this computer, this one, this one, this one. Then we have to reach this one. That's why you cannot send directly like this. This is not possible. So this is the disadvantages. So it is, that's what we do, unidirection. So it's important to note that data gets through, it's normally gets through rather than travels past each node. This means that a signal may be amplified before being repeated on the outward channel. So node to node around the ring. So after passing through each node, it returns to the sending node. So very simple. I don't know why they made such complicated. This could have been explained very simple way. It is important to note that the data gets through, rather travels fast to the each node, because gets through like this easy, moves like this more. This means that the signal may be amplified before being repeated on the outward channels. So node to node around the ring. So after passing through each node, it returns to the sending node. Like this is sending means pass, pass, and reaches the sending node. So this is how it works. This is one of the technique used earlier. So this is how it looks like. So advantages of ring topology. It's a short cable length. The amount of cabling involved in the ring topology is comparable to that of bus and is small relative to that of star. So this means that less connection will be needed, which will in turn increase network reliability. So that's one of the advantages. So short cable length than the star and bus topology, and less connections are needed. So therefore, it is more reliable. So in terms of reliability means it's a safe network. So no wiring closest space is required since there is only one cable connecting. So each node to its immediate neighbor. So it is not necessary to allocate a space in the building for wiring a closet. So normally what happens, this wiring closet required means, so whenever the electricity is passed through the conductors, it produces strong magnetic field. And these computers having some magnetic devices due to magnetism, so that has an impact on the computer system. So therefore what happens, so we have to keep the computers away from the cables. So whenever common bus, because more computers are connecting to the common bus, so there is electrical signal. So the closeness of the computer should be maintained when we use linear bus topology. There may be adjacent computers. So here what happens, only one wire is going through and each is following in the form of ring one after the other. So neighbors to its neighbors. So therefore it is not necessary because it goes in a unidirection. So this does not have an impact because there is no closed computers. So two computers not in parallel. It's like in the form of a series. So therefore the spacing is not an issue. So that's advantages. So no wiring closest space is required. That's one of the advantages compared to linear bus topology. So it is suitable for optical fibers. So using optical fibers offers the possibility of very high speed transmissions because traffic on a ring travels in one direction and it is easy to use optical fibers as a medium of transmission. So it's best suited for optical fibers. It's a high speed. So today FTTH, what we call, so that's the same technology that can be used. This is suitable for optical fibers. So this is something about the advantages of ring topology. There are some disadvantages as well of ring topology. So what are the disadvantages means? Node failures cause the network failure. So this is one of the most disadvantages of the ring topology. If any one of the computers goes down, that's a workstation, individual computers, then the entire network will be halt because each node must accept and the signal has to transmit it by all the computers. So one of the computers not working means from that point the network is not functioning. So that is the disadvantages of the, so node failures cause the network failure. Any one of the computer goes down, the whole network goes down. The transmission of data on a ring goes through every connected node on the ring before returning to the sender. If the node fails to pass the data through itself, the entire network has failed and no traffic can flow until the defective node has been removed from the ring. So this is the disadvantage. I think it's very easy to understand. No, there's nothing to be explained. So if any one of the fail, because already know the data will be from one node to another. So particular node, second node fails means from the second node data will not move to the third node. So then what we have to do means that has to be rectified. How do you rectify? First we have to remove the system or modify that system so that network can flow. So this is something about the drawback of ring topology. Difficult to diagnose faults. Identifying the error is also again difficult because which computer we may not be know where the error happens, so where data is lost, maybe in the second system, maybe in the third system, maybe in the fourth system, where actually data collision takes place or something is happened. Fault diagnosis also becomes very difficult. The fact that the failure of one node will affect all the other serious implication for fault diagnosis. It may be necessary to examine a series of adjacent nodes to determine the faulty one. So this operation may also require a diagnostic facilities to be built into each node. So as already I have told, we do not know where exactly which computer may not be functioning. So that identifying is requires checking all the computers over the network. So we have to make some diagnostic identification facilities to be built into each other node, self-identifying. So whether it is working in the networks or false and this station is not functioning, so that has to be built into the each node. That's additional things. That's also difficult. So fault diagnose, identifying the faults is also difficult. So difficult to diagnose the fault. Identifying the faults is also difficult. Network reconfiguration is difficult. It is not possible to shut a small section of the ring while keeping the majority of network working normally. So as I told, it's very, just if the computer is not working, just particular computers and remove it and use it. So that takes configuration, because we have to reconfigure, because through that only we have configured from this computers, all network like physical layers changes, the configuration has to be modified to establish a link with the next computer. So that's quite, that's a reconfiguration. You need a network engineers to come and fix it. So it's not so easy. Just you disconnect computers and start using the network is not possible. So therefore, reconfiguration is required. So network reconfiguration is difficult. So that's how these are the disadvantages. The first one is node failure causes the entire network failure, difficult to diagnose faults, and network reconfiguration is difficult. So these are the disadvantages of ring topology. So in exams, usually they may be asking explain different types of topology, or maybe write a note on ring topology or star topology, something like this. So I mentioned the advantages of or disadvantages of topologies, may be asking in the exam for 2 or 3 marks. So learn all these things. It's very important. So better you write and learn, practice. That becomes very important for your. Because these are all like theoretical, and if you do not imagine and learn, so you'll forget soon. That's why I want you to write and practice, then you will not be forgotten easily. Or just imagine how it real time and try to bring that concept into this real time, or the real time concept to the textbooks concepts, and then it becomes easier. Next is a tree topology. It's like hybrid combination of existing, like a star and linear bus. You can see here, this is a bus topology, like bus common cable, and you can see here, this is like a star topology, and they are interconnected. So this is called as a hybrid. This is called tree, like a root, have a root, and then you have like branches. And that's why it's also sometimes called as a tree topology. A variation of bus topology is the tree topology. Just modifying the bus topology, it becomes the tree topology. The shape of the network is that of an inverted tree with a central node branching and sub-branching to the extremities of the network. Very simple one. I think it's very, no need to think any panic here. So very simple. So it is like from the root we have like branches. You can see here, already I have told. So branches, this is like tree. So transmission this topology, takes place in the same way as in the bus topology. So normally through this data will be moved. So we go data, okay. So data moves through this, and then as already we discussed about, data will be sent and received on all the computers or the network through this common bus. In both cases, there is no need to remove the packets from the medium, because when the signal reaches the end of the medium here, so it is absorbed by the terminators. We have terminators like earthing, so grounding, so everything goes down. So terminators, it terminates. So tree topology is the best suitable for the application which have a hierarchical flow of data and control. We have a hierarchical flow of data, so moving from top to bottom, and we have to control. So data should go here and some data should go here, something like that. So that things can be done. That's the best suitable, and also easily we have to extend. Then also you have a small organization working with only this network, and we have increased. We have opened new branches in the same building, and that can be connected to this and forming the tree topology. And you have like a master main. Through this also you are communicating the entire network. This also additional branch in the same campus or some building. So small office, small organization, so we can modify, extend the network becomes easier when you use a tree topology. So since the tree topology is a modification of pure network topology, bus topology, it is a hybrid topology. So using already existing topology we are using, so it becomes a hybrid topology. So give an example of hybrid topology. Sometimes one marks, they mask. Then you can say give this tree topologies and a hybrid topology. So next, graph topology. In this topology, nodes are connected together in an arbitrary fashion. So a link may or may not connected to two or more nodes. There may be multiple links also. It is not necessary that all the nodes are connected, but if a path can be established in two nodes via one or more links called connected graph. So in a graph topology, what happens means there are many computers are connected. So like this, you can have many computers, and there may be a path, a link connecting from this computer to this computer or this computer to that computer. There will be a path. So that is, the path links all the computers over the network. So that is the graph topology. I think you can graph means there are many computers, not arbitrary. There need not be any particular fashion or any particular order, just arbitrary. So just in random connections. They may not connect to two or more nodes. There may be just randomly they are connected. There may be multiple links also. So the same computer may be connected by two or three cables, and it is not necessary that all nodes are connected. So in that type of network, so every computer is connected by other computer. No, need not be. A path can be established in two nodes via one or more links. So a path can be established from one computer to another computers using two or more nodes via, that is going through the mid. That's how graph will be formed. Like in graph means you can see the maps. If you take just imagination, a map where we have the destination, so there you have many way of reaching. So via this and via this, exactly the same way the graph topology, but is practically they are not using this type of topology, and also mesh topology is also not used. So in this topology, each node is connected to more than one node to provide an alternative route in the case of host is either down or too busy. It is an extension of a peer-to-peer network. So in this type of network means all computers in the network are connected to all other computers. You can see this connected to this network, and this also connected to this, and this also connected to this. Every computers in the network are connected to all other computers in the network. You can see here. So all the computers. So this is unnecessarily we are using, unless until every computer is sending data simultaneously at the same time, then you may use this type of network. So that practically does not exist. So therefore, this is the oldest technology. When the network concept came to existence, they thought like this. So we have to send for all the computers, and so all the computer has to be connected. Look at the wire, the amount of cables they have used is wasted. So therefore, this is not considered practically. However, earlier this mesh topology has been used. The mesh topology is excellent for long distance networking because it provides extensive backup, rerouting, and pass-through capabilities of communication is possible between any two nodes on the network, either directly or by passing through. So this function is needed in the event of line or node failure anywhere in the network. So the mesh topology is commonly used in a larger internetworking environment with the star rings and buses attached to each node, and is also ideal for distributed networks. So when in the network each host is connected to other directly, that is there is a direct link between each host, then the network is said fully connected. So this characteristic is termed as a fully connectivity. And as I told, so this type of one is the advantages of this type of network is, so data is a secured, data is safe, backup. So in anyhow the data will be sent from one computer to the other computer, whether the cable is problem or the other computers in the network is failed, no problem. But we have multiple options, many way of reaching source to destination. So therefore, these type of networks are used internetwork. That's an interconnection of network. So one network is connected to another network. So there we use this type of, imagine this connection is here, and like this we have a one more network. So all these are interconnected. That's how data will be transmitted more securely, more safely, alternatively. So each, whether computer is functioning or not, there is alternative path, so there we can use. So that is this type of networks suitable for distributed networks and also used in along with the star, ring and buses attached to each other. All type of networks can be interconnected. But this is practically when you use a local area network, normal network, we don't use this type of network because all computers need not be connected to all the computers. When you have a school, college or some small organization, so there we don't use this type of topology because a cable is wasted. But in internet what happens, the data has to be the server through the server to the client has to be reached. That is the main motto. So therefore they must provide in some other way. So they use this type of networks. So that's something about mesh topology. So next we have a transmission media. So we have understood how data transmit from one computer to other computers. We have discussed about the cable, how they can be connected physically. Now let us think of how data can be transmitted, transmission medium, how data will be transmitted from one computer to other computers. That is what we are going to discuss. So transmission medium, by transmission media or communication channel of network, it is a means that the connecting cables or connecting media are to be talked about. So that's how they are connected, how they can be exchanging data between two computers. That's what we are supposed to talk. The cables that connected two or more workstations are communication channels. That's physically they are connected. Already we discussed that one. So now let us learn how data can be transmitted. What are the media of data is sending from one computer to another computer. The twisted pair of cable. So we have first a twisted pair of cable, copper wire. So we use this copper wire. So twisted for different inches per length. So we'll discuss that how this exactly works. The most common form of wiring in data communication application is the twisted pair cable. So as a VGM, that is a voice grade medium. So that's a medium, how this voice grade, the data it is sent. It is the basis for the most internal office telephone wiring. It consisting of two identical wires wrapped together in a double helix. That's the cable. So where I think telephone cable you might have seen, there will be two, one for receiving and sending. So that will be covered by one more cable. That's outside. So that's exactly similar. We use this twisted cable. The problem can occur due to difference in the electrical characteristics between the pair. So as already told, length, resistance and capacitance. So that have a impact on the computer's network. For this reason, the LAN application will tend to use higher quality cable known as data grade medium. So because when they are close by, due to resistance offered and the signal may not transmit, the capacitors also they lose the content whenever data is transmitted. How they are capacitance to external, because electrical other things associated. So and also very length. So as the lengthy cable we use, so it may lose its strength. The data may not flow, the voice signal may not flow for a longer distance, and because of the resistance of the cable, that also leads to problems. Therefore, we use another high quality cable that is known as data grade. So voice grade normally we don't use, and we have a data grade medium. So that's called DGM. Different types and categories of twisted pair cable exist. So but we'll have only two things in common. One is the wires common in pairs, that is the pairs of wires twisted around each other. So normally the twisted pair of cable, there are different types come in different pairs. So first one, the advantages of this type of. So it is simple and physically flexible. So you can take anywhere and you can physically flexible, they can be kept anywhere. It can be easily connected. Yes, you can just connect them easily. It is easy to install and maintain. No, nothing, just you connect by yourself, it can be used. It has a low weight cable, so very simple. And it's inexpensive, it's not very expensive. So these are the advantages of twisted pair of cables. So it's a simple and physically flexible. I think cable you can see at home, whenever you only replace. When you have a telephone, you want to move from one place to other place, you do all those things, very simple. So that's a simple, physically flexible, it can be easily connected, it is easy to install and maintain. It has a low weight and it is inexpensive. That's advantages. Disadvantages, as already I have told, it's a low bandwidth. So make unsuitable for a broadband applications. It has no cables because of resistance, because of other electrical factors, so they do not support higher data transfer. So therefore, broadband application, this type of network may not be used because of high attenuation. So it is incapable of carrying a signal over a longer distance without the use of repeaters. Because as I told, whenever the signal is passed through, because the resistance offered by the cable, the data loses it may not travel for a longer distance. Then we have to use amplifiers, that's the repeaters. Additional cost is required, additional device is needed. So that's a disadvantages of this type of cable. It supports maximum data rates of 1 Mbps without conditioning and 10 Mbps with conditioning. So that's the speed is quite lesser. So 1 Mbps or with conditioning, so it can go up to 10 Mbps. The speed is limited. That's the disadvantages. These are the disadvantages of twisted pair of cables. So there are two types of twisted pair of cable. One comes with the unshielded twisted pair, UTP we call. So UTP cabling is just used for a variety of electronic communication. It is available in the following. So five categories. Category 1, VGA, voice grade communication only. Then we have a category 2, data grade with the 4 Mbps. Category 3, that is up to 10 Mbps. So DGM, so 16 Mbps up to 1000 Mbps. This is unshielded twisted pair of cable. The drawback of unshielded twisted pair of cable is they are susceptible for electrical interference. That's why they are less commonly used. So that's something about the unshielded twisted pair of cable. Next we have a shielded twisted pair of cable. So this type of cables comes with the shielding of the individual pair of wires, which further protects from external interference. But these also, like UTP, can have a maximum segment of 100 meters. The advantages of STP over the UTP is that it offers a greater protection from the interferences and crosstalk. So due to shielding, but it is definitely heavier and costlier than UTP and requires a proper grounding at both ends. So this is something about shielded. You can see here, so when you use additional things. So this can be protecting from electrical interference from other electrical devices, and it's normally, now it goes to be very expensive. Similar to that, exactly similar, but what is the advantages means it's protective, and also data is secure, more secure comparatively, and it's quite bulky, heavy, and also it's expensive. So this is something about different types of twisted pair of cables, that is unshielded and shielded. So next we have a coaxial cable. So we have two types of coaxial cable. So one is thick net and thin net. So in thick net, what is coaxial cable means? It is like the cable. It is used in a, what we call in a, what is that one? Cable TV. So where we have a copper conductor at center, and there are several layers of protective materials, and then we have covered. We have a copper conductor at the middle, that's a coaxial cable, and that we have several layers of protective materials. And you can see there a black cable inside that, also like mesh like that one, and also white, and there is a copper wire. That is what we call coaxial cable. And there is two types, thick net and thin net. Thick net, this is the form of coaxial cable, is thicker than the thin net. The thick net coaxial cable segment can go up to 500 meters long. Obviously, this thicker means thicker than the thin net, and it can go up to 500 meters long. Thin net, this is the form of coaxial cable, is thinner, and it can have a maximum segment length of 185 meters, lesser. And using this cable, so nodes have a maximum distance of, yes, of course, when you have 180 meters, that can be joined. So this is something about coaxial cables that's also commonly used. So next, this most commonly used this today is the optical fibers. So optical fibers, the data will be sent in the form of what you call light signal rather than electrical signal, thereby removing the electrical interferences. There is no problem. So in other medias, there is a possibility of electrical interference because maybe lightning or any other electrical devices connected or main power cable connected nearby, that may have a possibility of data loss. But when you use optical fibers, you do not come across with the electrical interference because the data is never sent in the form of electrical signals. So rather it sends in the form of light signals. So thereby removing the electrical interference and also offering high speed of high speed using a total internal reflections. So like optics. So that's why we use optical fibers, and nowadays FTTH we are using. That is what the optical fibers. The same thing. That's what we are discussing. Optical fibers consisting of thin strands of glass-like material, which is are constructed that carry a light source. That's what I said. At one end of the fiber to detector on the other end. So we have one end and we have a detector on the other end. The light source used either light emitting diodes, normally we use LEDs, or laser diodes. The data to be transmitted is modulated, converted into the light beam, light signals using the frequency modulation technique. So that's how it will be converted. The signals can then pick it up at receiving end. Again, it is demodulated, turned back to electrical signal. The bandwidth of the medium potentially very high. The offer that they're sending for LEDs, this is 20 to 150 Mbps, and higher rate is possible using laser LEDs. So this is something about optical fibers, and there are some advantages, and let us learn what are the advantages. It is immune to electrical and magnetic interference. That is, the noise is any form, the information is traveling on the modulated light beam. So we do not find anything. So electrical and magnetic interferences, there is no noise. We do not disturb because the data will be transmitted in the form of light signals. It is highly suitable for harsh industrial environment. So where industries means there's a lot of electrical connections will be there. There is a power consumption that's electricity is flowing around. So in those places we use a network of optical fibers. That's the most suitable, and it guarantees source transmission and has a very high transmission capacity. It guarantees, of course, because data is sent in the signals. There is no loss of data due to electrical and magnetic interference. So therefore, you can guarantee the source transmission has a very high transmission capacity. Definitely, it reaches the destination. Fiber optic cables can be used for broadband transmission where several channels are handled in parallel and where it is. So normally what happens, optical fibers are used for broadband transmissions. Normally when you use a broadband transmission, so we have many different frequencies. One is 10 Mbps, 100 Mbps or 2 Mbps running in parallel. So in those types, that's best suitable for using optical fibers. So that's that's a different channels we are using. So next we have another is signals from one antenna may be split up into propagate slide. So this I think is different onto some other. And these are the advantages of optical fibers, and we learn something about other than the physical. We go for non-physical. We go for radio wave signals, and also we learn advantages, disadvantages. We'll satellite communication. So these are the basic methods. So we use using physical connections. We have a twisted pair of cables, and we have a coaxial cable, and then we have optical fibers. So this is using physical connections. So transmission medium. So another we have without use like satellite communication or radio wave technology. Other things we'll be discussing in the next class. Okay, we'll continue in the next class.